To go over homework 2C. Let's look at problem number 6 in lesson 2.10. It says draw an isosceles triangle and a bisector of its vertex angle. Prove that the two smaller triangles form the congruence. So if you have a triangle, isosceles triangle, right? And then says bisect the angle, vertex angle. So this is the vertex angle right there, and these are the, we call it base angles. So bisect that, angles, right? That means this angle and this angles must be congruent. And do you see two triangles inside? And they said they are congruent, and why? So in order to prove that two triangles are congruent, you always have to use triangle congruence postulate, which could be SSS, SAS, or ASA/AAS. So use one of them to show that these two triangles are congruent. Let's go to problem number, lesson 211, problem number problem number 4. So for exercise 49, draw a picture that illustrates hypothesis, then determine whether the statement is true. If a statement is true, give a proof. If not, show a counterexample. So number 4 says, in a plane, two lines are perpendicular to the same line are parallel to each other. So this is a complete sentence. So hypotenuse is the subject. Subject says two lines that are perpendicular to the same line. So you should have two lines that are perpendicular to the same line. So if you have some line like this, and if you have two lines that are perpendicular to the line, they must be parallel. Okay, so first of all, is it true or false? If true, then prove it, right? So here's a hint. Hint is this is actually true. And if you extend that like this, and you have to use AIP theorem. Okay, AIP theorem, which says if you have something like this, and if you have congruent alternate interior angles are congruent, then the line must be parallel, right? So that's the AIP theorem, and then you have to use that for that problem. Let's move on to lesson 212. And let's look at problem number 5. Okay, so it says given, so we have something like this. We have H, L, K, J, and we have lines that intersects at M. Given HJ segments, so those are the given. HJ, segment HJ is congruent to segment HL, and segment JK is congruent to segment LK. Then prove that triangle HJM, which is the blue triangle, and segment HLM are congruent. Okay. Again, in order to prove two triangles are congruent, you have to use TCP, which could be SSS, SAS, ASA. So use one of these TCP to show that these two triangles are congruent. What are the givens? What givens are HJ is congruent to HL, and JK, this guy is congruent to LK. Then we got to prove that HJM is congruent to triangle HLM. So these facts actually gives you that this kite-looking figure is the kite. So if it's a kite, we know that, right? those diagonals of kites intersects 90 degrees. That's one property, right? And also we know that this guy, right? So it also intersects at the midpoint. Those are the two key properties of kites that you have. If you have kites, again, diagonals intersects perpendicularly, and one diagonal splits the other into two. So we know that this guy is congruent to this guy. So use those facts and put it together and write a proof for 212. Lesson 213. Let's look at problem number 3. So in exercise 3 to 8, prove each statement. Use a reverse list to write each proof. So it says if a triangle is isosceles, then the median from its legs to the vertex of its base angles are congruent. So if you have if you have isosceles triangle, right? Then the median from its legs, so these are the legs, right? These legs to the vertex. So median is the segment that goes midline to the vertex, midpoint to the vertex. So it goes like this, take the midpoint and then go there. Those are the medians. So they're saying that this guy is congruent to this guy. So let's actually label it. So let's say A, B, C, D, E. So we want to show that DC, segment CD, is congruent to segment BE. So that's what we want to prove, which usually we have at the end, right? Usually start it out with the givens and write the conclusion at the end. That's kind of like the way to write a proof, one way to write a proof. But the reverse, the problem says you got to use the reverse list. So we're going to go backwards. So in order to say this, what do you have to say? Well, you have to use CPCTC, right? So if you can prove that this triangle AEB is congruent to triangle ADC, right? Then you can say, if you say if you can show that those two are congruent, then you can use CPC to say the remaining parts of the triangles are congruent. So we want to use CPCTC. In order to say CPCTC, we have to show that two triangles are congruent. Right? In order to say two triangles are congruent, then we have to use TCP. SSS, SAS, AAS, right? In order to use TCP, you have to show that some parts are congruent. You have to show that three corresponding parts are congruent. So those are the hints. So, I'm going to give you one thing. Segment AD is congruent to segment AE. Well, actually, you can do that. You can compare triangle ABE and ACD if you want, but you can also do another way of doing it is compare DBC and EBC. And show that the three corresponding parts are congruent. Then you can follow backwards and write the proof.